So we have seen the naive algorithm to solve the subarray sum problem. Now we also saw the sliding window algorithm. Question is, why does the sliding window algorithm reduce complexity? Well, the point is this, right? That we look in the new algorithm with the sliding window, we are finding the complete subarray sum only once. Remember, that's what happens once in the beginning. But thereafter, we are just doing one addition, which is for the item that's entering the window, and one subtraction, which is for the item that is leaving the window. Now we can think of addition and subtraction basically being similar, like addition. So it's just one addition and one subtraction, regardless of how large the window is. Now remember, in the previous way of doing it, the naive algorithm, we were doing k minus 1 summations for every window. Here we are saying, okay, look, we are going to do k summations, actually k minus 1 summations once. But thereafter, we are just going to do two additions, which is one addition, one subtraction for every window, regardless of how large the k is. So if I were to look at all the windows that we are looking at, that is 2 times n minus k addition subtraction. So if I were to, let's say, add all of this, once again, you can say that, look, k is c times n, where c is, let's say, less than 1, much lesser than 1. You will realize immediately that now we are looking at an algorithm which is order of n, as against the naive algorithm, which was order of n square. So clearly, we have made a benefit here. We have, let's say, improved the complexity, time complexity of this. Intuitively, this makes sense because look, in the naive algorithm, we are redoing work which has already been done, and in the sliding window, we are in fact leveraging the work that has been done and just incrementally doing whatever extra needs to be done. Remember always, an inefficient algorithm is one where we are doing more work than what is needed, and that's the question to be asking, right? So basically, sliding window has done the job for us. The specific sliding window that we looked at here was a fixed size sliding window. We spoke about it several times. We call it sliding window, well, because it's like a window that is sliding across the list. We call it the fixed size because the window size was fixed. Remember, the left and right pointers moved together. In the while loop code, we had, left equals to left plus 1, right equals right plus 1. In the for loop code, one of them moved the for loop, one of them moved explicitly, but they nonetheless moved together. And hence we call it fixed size. Now we'll look at a new problem where we will have to use what is called a variable length sliding window. But I hope you're finding this interesting. Think about how the complexity is being reduced by using these smarter structures. As always, at YByte, we always analyze code in detail. We do fun activities to learn programming. Look at our website, www.ybyte.in, and forever enjoy coding. Take care. Thank you so much. Bye bye.